Example 3 says, consider the following function, f of x equals negative 3x squared plus 12x plus 11. Determine whether the function has a maximum or minimum. It is really easy to tell max or mins when you know the rule here for quadratics. All you have to do is look at the term with the highest exponent. So the highest exponent here is a 2. So I want to look at this term. If it is positive, my graph will look like a smiley face, like it's happy. If it's negative, my graph will look like a frowny face. It'll look sad. So again, positive looks happy, negative looks sad. So this graph is going to look like this, because it has a negative with my coefficient that has the highest exponent here. And this has a maximum. Right, this would have a minimum, lowest point. This would have a maximum, a highest point. Now it wants me to find the maximum or minimum value of the function. So I need to find what is this point, or what is my vertex, right? So we already know how to find the vertex. That's negative b over 2a gives me the x value of my vertex. So my a term is negative 3, b term is 12, c term is 11. So then when I plug in my numbers, x equals negative, and then my 12 over 2 times my a term, which is negative 3. Simplifying, I get negative 12 over negative 6. 12 over 6 equals 2, and a negative divided by a negative is a positive. So I have an x value of positive 2. Now that I have my x value of positive 2, I just need to plug it into my equation to figure out what my y value is going to be. So when I plug in my x value of 2, this just means what's my y value when the x value is 2. When I plug in that 2, I'm going to have negative 3 times 2 squared plus 12 times 2 plus 11. Simplifying, I have negative 3 times 2 squared is 4. 12 times 2 is 24. Negative 3 times 4 is negative 12 plus 24 plus 11. Negative 12 plus 24, or 24 minus 12 is just 12. And then our 12 plus 11 gives me a 23. So f of 2, or my y value when my x value is 2, is 23. So this is where the minimum or maximum is. It's how far sideways. But if I'm wanting to know what it is 23. So find the maximum or minimum of the value. Function, let me reread that. Find the maximum or minimum value of the function. The value itself is the 23, right here. So 23 is our answer. State the domain or range. That's also from your entry task. So your entry task had you say whether the domain was x or y values and the range was x or y. We know that the domain is the x values that are defined for our function. Most of the time, we'll get to ones where it's different, but most of the time your domain is just all real numbers. And we're going to use that shorthand like that for all real numbers. But we're also eventually going to work on notation. For now, you can just write this, that means all real numbers, meaning that you can plug any x value you want to in for this equation, and you'll be able to get an answer. There's going to be some problems where that doesn't work. Like if you plug in an x value, you won't be able to get an answer because weird things happen in the math. But most of the time, for now, and really with all polynomials, it will work. It's just all real numbers for our domain. For our range, that's the lowest and the highest numbers that we ever get. So on this graph, the lowest we ever get, well, it goes down for forever. And it only goes up until 23, right? We said our maximum y value is 23. So our range is the y values have to be less than or equal to 23. They can be smaller than 23, but they can't be bigger. So anything smaller than or equal to 23 is our range. So there's our domain and range for number